The goal, to be a sustainable university, is one of 5 key goals identified in the Griffith 2020 strategy that sets the direction of the university. The sustainability plan discusses a range of domains in which the university aims to be sustainable. These include everything from the executive through to digitisation. Not all of the domains herein are necessarily explicitly relevant when we talk about sustainable building design. Perhaps the most relevant to these buildings are the domains of energy, planning and development, and perhaps tangentially transport. The university has an objective to be an exemplar to the wider community by demonstrating best practice with regard to environmental, social and economic sustainability. So we can have a look at how well the university is meeting this objective through analysis of 2 buildings. They are GO2, Clinical Sciences, the home of allied health at Griffith Gold Coast, and GO9, a multi-building compound for engineering including office space, workshops and laboratories. Let's talk about energy. The university has a goal to minimise energy consumption while providing best practice facilities for teaching and research. We all know by now just how much of all energy consumed in the developed world goes straight into its buildings for air conditioning, lighting and appliances and so on. The university has initiatives to reduce energy consumption and greenhouse emissions per gross floor area, and this is quite measurable as we can see in Table 1 and Figure 1 of this report. GO2 has a gross floor area of 4,576 square metres and uses 101,664 kilowatt hours annually. Its peak consumption is in January over the summer, and this is likely due to energy demand for cooling and air conditioning. It has a 6-star neighbours rating. GO9 comparatively has 2/3 the floor area of GO2 at 3,101 square metres and uses a whopping 433,412 kilowatt hours annually, more than 4 times GO2, and this is likely due to the high power consumption from much of the equipment in the labs and workshops. Its energy consumption is peaky. This is maybe due to fluctuating demand for services and the transient nature of projects which happen in the lab. It still has a 4.5-star neighbours rating, so they're doing something right. Planning and development. The university has design guidelines for new buildings which include, among other things, sun directional studies to mitigate heat load and loss, manage lighting and air conditioning to ensure efficiency, motion detection systems to control air conditioning and lighting, and low energy lighting. We've done a sun directional study here. Let's have a look at figures 2 through 7. These images are not to scale, they are illustrative. Sections are taken north-south and looking west. The GO9 section is a little more northeast-southwest so that we can still look along the main axes of the building for illustrative purposes. GO2 gets a lot of northern sun all year round and is not particularly vulnerable to heat or light on the southern end. Even in summer, afternoon sun hits the windows at a mild angle. GO9 does get sun on its southwestern faces which are not shaded. GO9 in the winter is interesting. The height and pitch of the office block doesn't impede the workshop's access to sunlight. Let's have a look at Figure 8. We can see examples of simple passive shading solutions to keep heat off the windows, and we can see in Figures 2 through 7 how these might perform. Figure 9 shows us examples of natural day lighting in these buildings as well as some of the artificial lighting deployed here. Figure 10 shows the predominantly artificial lighting of internal corridors. If we examine the photo essay in Figure 8 a little more, there's something about the windows which you should see they all have in common. They are all closed, and this is true of all the windows of these buildings that are not photographed. Despite the external shading to avoid glare and heat, many windows also have their curtains closed. They are all of them again dependent on artificial lighting. Figure 11 is describing potential for cross-ventilation in both buildings, but this will rely on open doors in the hallways, and it's not reasonable to expect that this will always, if often, be the case. A tour of GO2 in early March was quite unpleasant. It's actually very hot and stuffy in there, especially in the western and upper floors. GO9 is not bad, but it clearly benefits from air conditioning. Transport. The goal is to maximise the use of sustainable transport options. Now, a building won't make people carpool, but sensible planning gives people options as to how they can best access the campus. The university's priorities include continuing to work with ministers translinking local governments to improve public transport, to investigate strategies to support the use of public transport and carpooling by staff and students, and to continue to provide additional end-of-trip facilities. This is something I think the Gold Coast campus has actually done quite well. Figure 12 shows us a map of the campus and where these buildings are situated. Around each building I've drawn a 400-metre walkability radius. You can see that each building is within around a 5-minute walk of any suitable transport option, whether it's the tram, there's ample parking and there are end-of-trip facilities for cyclists who might want to freshen up after a ride. There are plenty more options available on campus, other than the ones that are on this map, but it does show that there are amenities within comfortable walking distance of each of these buildings. In conclusion, I hope this brief look at these buildings has suggested some of the ways sustainable design is or is not working at Griffith University and how building design impacts a broad approach to sustainability.